Okay, today we're going to talk about compound inequalities. Well, compound inequality is two or more inequalities that are connected by the words and or or. Okay, when they're connected by the word and, a compound, it's the overlapping of the two inequalities, which means for the true part of that inequality is one that fits both conditions. So let's just take a look at this one. We have negative 2 is less than or equal to x minus 3 less than 4. Well, there's actually two inequalities here. We've got one that says negative 2 is less than x minus 3, and we have a second one that says x minus 3 is less than 4. Well, the process of solving them is just to solve each one individually and graph it. Take a look at that. So we'll go ahead and solve the one on the left first. It says negative 2 is less than or equal to x minus 3. Well, we need to isolate x, so we're going to add 3 to both sides. When we add 3 to both sides, we wind up with 1 is less than or equal to x. When we get ready to graph this one, well, we know we want a solid dot on 1, and that will graph it going to the right, because remember, when the variable's on the right side, we need to read it backwards. So it's basically x is greater than or equal to 1. Then we go ahead and solve the second one. So x minus 3 is less than 4. To isolate x, we need to add 3 to both sides. When we add 3 to both sides, we end up with x is less than 7. So we know that we're going to need an open circle on 7, and that we're going to shade it to the left because it's less than. Now, let's go ahead and take a look at this. This one says 1 is less than or equal to x. Okay. And then over here we've got x is less than 7. So we put it back together. So we've got 1 is less than or equal to x, and x is less than 7. When we take a look at these graphs, well, here's one. So the graph of the first one is x is greater than or equal to 1. So here's what that looks like. The next one is x is less than 7. So here's our 7. Since it just says less than, we're going to use an open dot. Now remember, at the beginning I said if it's and, it's the overlapping of these two. So the only part that would make this true in both cases would be the point starting at 1 and including 1 all the way up to 7, but not including 7. Any point along this line would make either one of the shaded area would make either one of these a true statement. Now let's take a look at what it means to be if it's connected by the word or. Or means it's the union of those two graphs. If our number makes either condition true, well then it's a true statement. So in this case we have x is greater than 2 or x is less than 1. So let's take a look at these graphs. If we do x is greater than 2, we're going to start at 2 with an open circle, and it's greater than, so we would shade it to the right. So that's what this graph looks like. And then if we go ahead and graph the second one, we have x is less than or equal to negative 1. So that one we're going to have a solid dot on negative 1 and shaded to the left. So that's what we're going to look like here. Now remember, this is the union of those two graphs. Okay, so either condition makes this true. So when I put this on the number line, we're going to have something that looks like so. So if our number, if we plugged it in, either one, if it was negative 1 or less, it would be true. Or, because it's or, I win either way. It's kind of like a competition. On this one, I'm going to win either one I pick. If I pick the number 3, it doesn't make this side true. It doesn't make the green side true, but it does make the purple side. So yeah, That would be 3 would be a number. But so would negative 2, because it either has to make this one true or this one true. Okay? In the next video, we'll take a look at some examples and study these a bit further.